The Lexical Offset Resolution Engine, or LORE, is a subsystem responsible for mapping character positions within tokenized text streams to their corresponding byte offsets in the source data. This document describes the internal mechanisms, configuration parameters, and operational procedures for LORE version 4.2. All operations are performed on immutable input buffers. The engine maintains state through stateless computation over fixed-size windows. The resolution process begins with the byte buffer initialization phase. Each input stream is divided into fixed segments of configurable length, defaulting to 65,536 bytes per segment. Segment boundaries are aligned to character boundaries using UTF-8 decoding logic. The engine scans forward from each boundary to locate the next valid character start position. Misaligned boundaries are flagged but do not halt processing. Offset computation relies on a two-phase accumulation model. In Phase 1, a preprocessing pass counts character boundaries within each segment and stores partial sums. Phase 2 uses these pre-computed sums to calculate absolute offsets without rescanning. The accumulation table is regenerated when segment boundaries change or when buffer rotation occurs. Lookup time is constant regardless of stream position. Multi-byte character sequences are handled through a state machine embedded in the lookup path. When a query position falls within a multi-byte sequence, the engine rewinds to the sequence start and redecodes to determine the true character boundary. This operation is performed in place without allocating temporary buffers. Sequences longer than 4 bytes trigger an advisory log entry, but do not cause errors. The accumulation table structure consists of fixed-width entries containing segment identifiers and cumulative character counts. Each entry occupies 16 bytes. Table capacity is determined at initialization and cannot be resized without invalidating all existing handles. When the table approaches capacity, a compaction routine merges adjacent segments with low character density. Compaction runs asynchronously during idle periods. Query interface methods accept a byte offset and return the corresponding character position. The primary query function, resolve_char_offset, performs a binary search on the pre-computed accumulation table followed by a linear scan within the target segment. Average latency is logarithmic in segment count plus linear in segment size. Maximum latency occurs when the query target falls near segment boundaries. Caching mechanisms reduce repeated lookups through a small in-memory cache of recent query results. The cache uses a least recently used eviction policy with a fixed capacity of 256 entries. Cache hits are identified by exact byte offset matching. Entries become stale when the underlying buffer region is modified or when the segment table is recomputed. Staleness is detected lazily during lookup. Configuration parameters control engine behavior through a read-once initialization structure. Segment size, cache capacity, and compaction thresholds are supplied at instantiation and remain fixed throughout the instance lifetime. Parameters can be overwritten globally through a configuration file parsed at startup. Invalid parameter values default to documented constants rather than raising exceptions. Parameter changes require engine reinitialization. Error handling follows a degradation strategy rather than fault containment. When a character boundary cannot be determined with certainty, the engine reports the nearest valid position and logs a warning. Corrupted segment boundaries are repaired by forward scanning. The system never terminates a query due to malformed data. Diagnostic information is written to a circular buffer retained for post-mortem analysis. Batched query operations are supported through a bulk interface that processes multiple offset positions in a single pass. The bulk query function accepts an array of byte positions and returns an array of character positions in the same order. Bulk operations amortize segment table lookups across multiple queries. Batch size limits are enforced to prevent excessive memory consumption during processing. Buffer rotation is the process of shifting input data when stream processing advances beyond certain thresholds. During rotation, the accumulation table is updated incrementally rather than fully recomputed. Rotations are triggered when the oldest segment becomes unreferenced by any active query handle. Rotation latency depends on the number of segments being discarded and is typically negligible. Reverse offset queries translate character positions back to byte offsets using an inverted lookup table. This table is constructed during the same preprocessing pass as the forward accumulation table. Reverse lookups use identical binary search algorithms with slightly different comparison semantics. Reverse queries are marginally slower than forward queries due to cache locality patterns. Concurrent access to the engine is permitted for read-only query operations. Shared locks are acquired automatically during resolution. Write operations, such as buffer modification or table recomputation, require exclusive locks and will block incoming queries. Lock contention is monitored and reported through standard metrics interfaces. Deadlock is prevented through strict lock ordering conventions. Memory consumption is bounded by segment count and cache capacity. The accumulation table grows linearly with segment count. Cache memory is fixed size regardless of workload. Temporary buffers used during character decoding are stack allocated with a maximum size of 1024 bytes. Heap fragmentation is minimized through pre-allocated memory pools managed separately from the query path. Diagnostic output includes trace logs of all resolution operations when verbosity is enabled. Each log entry contains the query position, the result, and the number of segments examined. Performance counters track cache hit rates, average lookup latency, and compaction frequency. Metrics are exported in JSON format at configurable intervals. Historical metrics are retained in a rotating buffer. Shutdown procedures perform orderly cleanup without forcing active queries to terminate. Pending operations are allowed to complete before the engine enters a quiescent state. The accumulation table and cache are serialized to persistent storage if configured. Upon restart, tables are restored from the snapshot rather than recomputed. Restoration time is proportional to table size.